Welcome children. Now we are going to discuss about the chemical effects of electric current. Which is the unit chemical effects of electric current. You know, this is a metal, that means a copper wire. This copper wire can conduct electricity. So metals are good conductors of electricity. But you see, this chalk or the liquid, this we taken. These liquids, that means metals we know are good conductors, but substance like chalk, wood, etc. are poor conductors of electricity. Which are the good conductors? All the metals are good conductors of electricity, but substances like chalk, wood, plastic, etc. are poor conductors of electricity. Now see, this is a liquid taken, that means here it is given as a vinegar. We want to know this type of liquids are also conductors. That means liquids are also conductors, that we want to know. Liquid can conduct electricity. That is the things we want to know now. Once more, that means what is the property of metals? Is it a good conductor or a bad conductor? What? It is a good conductor. Then, like chalk, wood, plastic, these are all usually we say as poor conductors or bad conductors. Otherwise, sometimes we used to say as insulators. Now we want to know liquids also can conduct electricity. Liquids also can conduct electricity. We want to discuss about liquids also can conduct electricity. For that, first of all, we can discuss about the tester that you made in class 6. That tester is used to what is to understand the conductivity of a circuit. Now, when we join the free ends of the conductor, that means the tester which you made with a bulb and cell, and this is the tester that you made. Here you want and this free end joint. If the bulb is glowing, then the circuit is complete. Then the tester is working. When you join the free ends of the tester, if the bulb glows, then we can say the tester is working. When you say your tester is working, when you join the free ends of it, then if the bulb connected in that circuit is glow, then we can say that tester is working. And usually we used to make this kind of this is the actual tester. This is the actual tester we used to use to identify the current, presence of current. That means just we insert into the phase line, and when we press this bottom, then the bulb inside it we can see glowing. That is used to find electricity presence or not. That is presence of electricity we can identify by using this tester. But you made another type of tester, and if the tester working, then the bulb will glow. If suppose if the bulb is not glowing, suppose when you check the bulb is not glowing, that means your tester is not working, and it's a reason you can find it. Sometimes the connections you made here is loose, then tight the connections, then also if the bulb is not glowing, then the bulb sometimes it may be fused, then replace it one, then you can see that the bulb is glowing, then the tester is working. Now we want to find out these liquids also can conduct electricity. That is the things we want to understand now. We constructed a tester in our class 6, and now we want find liquids can conduct electricity with the help of that tester. For that, take some bottle caps like this or rubber cap like this, and in it take these solutions, that means vinegar or lemon juice in it you take, and then if you dip the free end of, that is your tester, and this is the battery. Instead of cell, use a battery and bulb, and the free end of the tester. When you dip this solution, that means here we taken with lemon juice in one bottle cap and another one vinegar. Then you bring the ends of the free ends of this one, and if the bulb is glowing, then the circuit is complete. If the bulb is, that is the free end, when we dip in this lemon juice taken in the bottle cap or vinegar taken in the bottle cap, if the bulb glows, then the circuit is complete. That means this liquid conducts electricity. If this one is not glowing, that means this liquid is not conducting. That means what we did here, the free ends of our tester dipping into the lemon juice or vinegar taken in the bottle cap. Then the bulb, if it glows, then the circuit is completed. And the liquid conduct electricity. Sometimes the bulb may not glow. One thing you want to remember, the distance between the free end not more than 1 centimeter. That is the distance between these two free ends not more than 1 centimeter. If it is at a too large distance, then the current conduction may not happen. And also, when you dip these ends, that does not come in contact directly. That means if the liquid conducts electricity, then what we can observe, the bulb glows. If it does not, then the bulb does not glow. And what we did here, we want to find out if this lemon juice or vinegar can conduct electricity through it. Or otherwise in general, we want to find out what is liquids can conduct electricity. And the circuit which we used here, instead of cell we use battery to get more current, and bulb, and here is what the lemon juice or vinegar taken in the bottle cap. Now see, why this bulb glowing? See, see when current is flowing through this bulb, there is one filament. There is one filament in the bulb. That filament will get heated up. That means the filament in the bulb get heated up, and from that light is emitting. If the current is weak, if the current is not sufficiently strong, then the filament does not get heated up sufficiently or that much to emit light. Then even though the circuit is completed, then also the bulb does not glow. The reason for bulb is glowing means the filament in the bulb gets heated up in the red hot condition and to the white hot condition, from red hot to white, and from there light is getting. If the current is not sufficient or if the current is weak, then what happens? The filament does not get heated up sufficiently and this does not emit light. Then also the circuit may complete, the liquid is conducting electricity. Here the conduction of this zone is not strong as or here the we cannot say that this liquid is a good conductor at that case. Now see, we can make one tester which can measure weak current, which can use to measure weak current. See, instead of this bulb, we use LED. LED means light emitting diode. Light emitting diode. The property of this one is it requires very low current. That means to glow, this one required very low current. So instead of in our circuit, that means with this cell, if we use instead of bulb an LED, LED means like this on cap there are two leads. One lead is little longer than the other. One thing we want to remember, the longer lead, suppose this one is longer and this longer. The longer lead is to be connected to positive. Positive means to this one, and shorter one, that is to negative of the battery. And now this end, if we dip the liquid containing bottle cap, then we can see the LED is glowing. That means this liquid, if it is vinegar or lemon juice, that conducts electricity. So here, what kind of tester we use here? What kind of tester we made? A tester which can measure weak current, or a tester which works at low current. Here what we use? Instead of bulb we use LED. Here two connecting leads. Here two connecting leads are or otherwise connecting wires. One is bit longer than the other, and this longer one is connected to what is positive and shorter one is to negative. Now we can make another kind of tester by using magnetic effect. And third type tester that we can make with the magnetic effect. Here you see this is a tester. In a compass, see a compass is arranged in a case, and we wound this conducting wire, and the two free ends when connected to See here, this is a compass and this compass is arranged inside a, this compass is arranged within the case, and if current is passed through this one, see, when the current is passed through this on, we can see, that means this compass is deflecting. See, when current, we know that means when current passes through any conductor, when current passes through any conductor, a magnetic field is produced. A magnetic field is produced. So here we use what is a magnetic effect of electric current. How it is made? You can also make this one. See, take the case of a matchbox and wound the metallic wire around it. Metallic wire, that means you wound it, and then we get two free ends, and one end is connected to the positive of the battery, and another one end is to the another one end you keep as free. Then the second terminal we take. From the negative of the battery, we can take as another free terminal. When these two terminals we dip, see these two well connected together, we can see there is deflection of this compass, and if this free end well dipped in this solution, we can see, that means here we took what is vinegar in on bottle cap, and if these two free ends when we dip in this, we can see there is a deflection. That means our magnetic compass is arranged in this. Here is the compass, and we know what is a magnetic compass, always in the north-south direction. Always that will be in the north-south direction. What we did, that means here we wound copper wire over this box, and one end of this one is connected to the positive of the battery, and the negative taken, and here is the bottle cap in this vinegar, and the other end is taken this way here, and from this second, now the two terminal is in this, that is free end of this tester is in the liquid, that is in vinegar or lemon juice. Now what we can see, here is a deflection we can observe. Here is a deflection we can observe. That means this vinegar, what does is a conductor. Similarly, when we dip this free ends in a bottle cap taken lemon juice, then also we can observe deflection. That means after completing this, at first take it and wash it, dry it up, wipe. After wiping it dry, and then dip in the lemon juice. In the same manner, when we dip it in the water, and also different substance like this, you want to observe, is it a good conductor or a bad conductor? That means lemon juice. Here is one column given. Compass needle shows deflection, yes or no. And good conductor or poor conductor. The first one, lemon juice, compass needle deflects, so it is a good conductor. Vinegar, it also shows that means when the free end of the tester dips in vinegar, we can observe there is a deflection. So it is also a good conductor. That means third one is asking tap water. Tap water, when we dip the free end of the tester, there is also deflection. Then it is also a good conductor. Then vegetable oil. Suppose vegetable oil such as coconut or sunflower oil, etc. When we dip the free end of the tester, that does not show any deflection. That means it is a poor conductor. And in milk there is an acid, so that is also a good conductor. It also shows deflection. In the case of honey given here, that does not, when we dip the free end of the tester, we cannot find any deflection. That means it is a bad conductor. In the way, if we dip the free end of the tester in mercury, we know mercury is a metal that is in the liquid form. Mercury is a metal that is in the liquid form, so it is also shows deflection. It means it is also a good conductor. Then fuels, which are the fuels we use: kerosene, petrol, diesel, etc. If we dip the free end of this tester, that does not show any deflection. That means we cannot observe any deflection in the combust. That means it is a bad conductor. And some soda compounds, if we dip the free end of the tester in a soda compounds, then also we can see there is a deflection in the combust needle. That means it is also a good conductor. So some of the liquids are good conductors and some others are bad conductors. Some of the liquids are good conductors and some others are bad conductors. Examples for good conductors: liquids which have good conductivity. Which are they? Vinegar, then lemon juice, milk, then mercury, tap water, etc. These are all conducts electricity, so we can say these are all good conductors of electricity. Now that means vinegar, lemon juice, milk, mercury, tap water and water taken from the well, etc. are also good conductors. Why these are all? Because this tap water or water taken from the water taken from the well, that are all good conductors. Why? Because in that all certain salts dissolved or certain minerals in it. Some minerals that is in the tap water or well water, etc. Some of the minerals are beneficial to our body. Some minerals in the water is beneficial to our body, but because of that minerals, water become a good conductor. Because of that, we are advised to not handle electrical appliance or use electric switches while the hand is wet, because when the hand is wet, that is a good conductor that may so we can get electric shock. Because of that, we are advised not to handle electrical appliance with wet hand. What is the property of the tap water and well water? There is some salt dissolved, and also it contains minerals. When these are present in it, they are good conductors. But see, some substance which does not conduct electricity, some liquids, which are that is vegetable oil, honey, fuels, etc. These are all does not conduct electricity through it. These are all does not conduct electricity through it. But this can conduct electricity through it. Now, when we keep the free end of the tester separate, there is an air gap. There is an air in between the terminals. We know that what is air is a poor conductor of electricity. We know air is a poor conductor of electricity. Because of that, when the terminals of our tester open, that means when the terminals of the tester is open, see there is an air gap, so there is no deflection. But we know what during lightning, electricity is conducting through air. During lightning, electricity is conducting through air. So electricity can conduct through air also. So in suitable conditions, most of the material conduct electricity. Most of the material, so we can conclude that most of the material can conduct electricity through it, some certain conditions. So we can classify metals, that means substances as, not metals alone, substances as good conductors, and poor conductors of electricity. So broadly we can classify materials into good conductors and poor conductors instead of conductors and insulators. That means some of the insulator in certain conditions can conduct electricity. So in general it is better to consider materials as good conductors and poor conductors instead of what is conductors and insulators. Instead of conductors and insulators, we can classify this into what is good conductors and poor conductors. Now, see, distilled water can conduct electricity. That we want to know. But distilled water can conduct electricity. As before, take 2 tablespoons of distilled water in this cap. In this cap with a distilled water. Then dip the free end of the tester. Free end of the tester. Then observe. The needle inside it deflects or not. That means when we dip the free end in this distilled water, there does not show any deflection. That means no deflection in a compass needle. In a compass needle there is no deflection. That means distilled water is not conducting electricity. Distilled water is not conducting electricity, or here circuit is not completed. Now, if we add a pinch of common salt. Now we add a pinch of common salt into this distilled water. Then we can observe there is reflection, and means now the salt solution becomes a conductor. Now when we add common salt to this distilled water, it becomes a salt solution, and it now becomes a conductor. Usually distilled water is not a conductor actually. Distilled water is not a conductor. But when we add to this a pinch of common salt, that means sodium chloride, then this solution become what is a salt solution. This become a salt solution, and it now conducts electricity. How we can find this now conducting electricity? By the diffraction of this magnetic compass. By the diffraction of the magnetic compass, we can find the conduction of this distilled water with common salt solution. Okay, the distilled water with common salt, that we can find out. That means one thing we understand, when we add common salt to this one, this distilled water becomes a conductor. Now we want to find out in all the substance when we add to this distilled water, that become a conductor. That we want to find out. For that we took 3 caps. In the 3 caps we took that means 2 tablespoons of distilled water. In these 3 caps there is small amount of 2 tablespoons of distilled water. Then in the first one we add a few drops of lemon juice or dilute hydrochloric acid. Dilute hydrochloric acid. In the first bottle cap with distilled water, we add some lemon juice or hydrochloric acid, dilute hydrochloric acid. And in the second, we add some base. Here some lemon juice is acid. Here we add some base. That means some sodium caustic soda or sodium bicarbonate or etc. In the third, this one, we add some sugar. But which is the activity we are going to do here? We want to find out distilled water become a conductor when we add any salt to this one or any substance to this one, is it become a conductor. For that, in the first cap we took 3 bottle caps, and in each we took 2 tablespoons of distilled water, and in the first cap we add some acid such as lemon juice or hydrochloric acid diluted one, and second one is some base is added to this one. Example, caustic soda is added, and in the third one some sugar is added to this one. Then as before, we observe the conductivity by using our tester. Now we can see this distilled water with lemon juice or hydrochloric acid that conducts by deflecting the compass needle, we can understand it. That means this become a conductor. And the distilled water with a base or caustic soda added, that also now conduct electricity. But the distilled water in which we added sugar, that is not conducting. That means from this, what we can understand is most of the solutions or liquids or salt solution that can conduct electricity, and some of them does not conduct electricity. Okay, from this activity, these two conducting electricity and this one is not conducting electricity. Now we can discuss once again what are the things we come across today. First of all, we discuss about liquids can conduct electricity. Okay? Liquids can conduct electricity. What is your conclusion? ECT can conduct electricity, or all the liquids conduct electricity at the same rate. From our observation, we find some of the liquids are good conductors. Some of the liquids are good conductors and some others are not good conductors. Then our tester with LED. What is actually LED? Light emitting diode. In the LED, one lead with a longer than the other. This longer lead we will connect it to which terminal of battery? Can you remember? This long lead is connected to positive or negative terminal of the battery. This long terminal or lead, it is called, this long lead is connected to positive of the battery. Always we want connected to the positive of the battery or cell, and this one to negative. Why? We replace another things you want to remember. Why? We replace bulb from our tester and use LED bulb. If the current is in bulb, if the current is not too weak, then the filament does not get heated up sufficiently and light does not emit from it even though circuit is completed. So when we use LED, we can measure very weak current also. Okay. To measure very weak current also, to identify very weak current also, we use LED instead of bulb in our tester. Then another tester we used. What do we use there? Which effect of electric current? Magnetic effect of electric current is used. Here, see. You know, magnetic compass. Magnetic compass is placed in a case. That means in a case, and we wound this copper wire over it, and when the free end is connected to the cell, we can see deflection in this. We can see deflection in this. That means when current passes through this, a magnetic field is producing, and due to that magnetic field, this compass is deflecting. So we use a magnetic effect of electric current here. Here we use a magnetic effect of electric current in this tester. What is the advantage of this one? By using this, we can find out a very small current also. We can find out a very small current also. Then, by using this tester, we check the conductivity of some liquids. Which are the liquids we find out the conductivity of? That means on lemon, it conducts. That means here we can see deflection. So it is a good conductor. Then vinegar, deflection, good conductor. Then milk, deflection, good conductor. Then tap water, we can see deflection, good conductor. Then if we use mercury, deflection, good conductor. These are some of the examples of liquids that conduct electricity, and shows deflection in the magnetic needle. So these are the examples given in our text to find if they are conductors or not. And some other given, and among that one is vegetable oil, then fuel, here no deflection. No deflection, so poor conductor. Examples of this one, and also distilled water, that also poor conductor. Then we check the conductivity of distilled water. How we check the conductivity of distilled water? Distilled water we took in a bottle cap, then connected it to a tester. That means the free end of the tester is dipped in this distilled water. Then that does not shows any deflection. This means that is not a conductor. Then what happened when we add a pinch of common salt? When we add a pinch of common salt to this distilled water, what happened to its conductivity? Now the distilled water becomes a conductor. But when we add a common salt, otherwise it is not conducting. Then we want to know one more thing about the conductivity of distilled water. If we add some other material, then it can conduct electricity. For that, what we did in distilled water, we took 3 bottle caps, and in the first we add what is dilute hydrochloric acid, dilute hydrochloric HCl, hydrochloric acid, and in the second bottle we add some base, such as caustic soda. Then in the third we add sugar. In the third we add sugar. So we observe that this distilled water with the hydrochloric acid with the base they are conducting, but a distilled water in which we add sugar, that is not conducting. That means from this we can understand that most of the liquids, solutions, salt solutions, etc. can conduct electricity. Okay.